Electrical panels are a critical component of any electrical system, serving as a central distribution point for electricity throughout a building. Ensuring that these panels meet all applicable safety standards and receive proper approvals is paramount to protecting people and property from electrical hazards. The process of approving an electrical panel involves several key steps and considerations. Firstly, the panel itself must be manufactured to meet specific industry standards. In the United States, Underwriters Laboratories, or UL, is the most common certification body. UL certification indicates that the panel has been tested and found to comply with established safety requirements. These requirements cover various aspects of the panel's design and construction, including its materials, wiring, and overall structural integrity. Secondly, the installation of the electrical panel must adhere to the National Electrical Code, or NEC. The NEC provides a comprehensive set of guidelines for electrical installations, covering everything from wiring methods to overcurrent protection. Local jurisdictions typically adopt the NEC as the basis for their electrical codes, and electrical inspectors enforce these codes to ensure compliance. An electrical inspection is a crucial step in the approval process. A qualified electrical inspector will review the panel installation to verify that it meets all applicable code requirements. This inspection may involve checking the wiring connections, grounding system, overcurrent protection devices, and other critical components. The inspector will also ensure that the panel is properly labeled and that all required clearances are maintained. There are several key areas that an electrical inspector will focus on during a panel inspection. Firstly, proper grounding is essential for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazards. The inspector will verify that the panel is properly grounded to the building's grounding electrode system, which typically consists of a ground rod, metal water pipe, or concrete encased electrode. Secondly, overcurrent protection is another critical safety feature. Circuit breakers and fuses are designed to protect circuits from overloads and short circuits. The inspector will verify that the panel contains the correct size and type of overcurrent protection devices for each circuit. They will also check that the overcurrent protection devices are properly labeled and that they are functioning correctly. Thirdly, wiring methods must comply with the NEC. The NEC specifies the types of wiring methods that are permitted for different applications. The inspector will verify that the wiring within the panel is properly installed and supported and that it is protected from physical damage. They will also check that the wiring connections are secure and that they are made with approved connectors. Fourthly, proper labeling is essential for identifying circuits and equipment. The inspector will verify that the panel is properly labeled with circuit numbers, breaker sizes, and other relevant information. This labeling helps to ensure that electricians and other qualified personnel can safely work on the electrical system. Fifthly, clearances around the electrical panel must be maintained. The NEC specifies minimum clearances around electrical equipment to provide safe access for maintenance and repairs. The inspector will verify that these clearances are maintained and that the panel is not obstructed by storage or other materials. When an electrical panel installation fails to meet code requirements, the inspector will typically issue a list of deficiencies that must be corrected. These deficiencies may range from minor issues, such as missing labels, to more serious problems, such as improper wiring or grounding. The electrical contractor is responsible for correcting these deficiencies and requesting a re-inspection. Once the deficiencies have been corrected and the installation meets all applicable code requirements, the inspector will approve the panel installation. This approval typically involves signing off on the electrical permit and issuing a certificate of compliance. It is important to note that electrical codes and standards are constantly evolving to address new technologies and safety concerns. Electricians and electrical inspectors must stay up to date on the latest code changes to ensure that electrical installations are safe and compliant. Continuing education courses and professional certifications can help electricians and inspectors stay informed about the latest developments in the electrical industry. In addition to the NEC, other standards and regulations may apply to electrical panel installations depending on the specific application. For example, industrial facilities may be subject to additional requirements under the National Fire Protection Association or NFPA 70E standard for electrical safety in the workplace. Healthcare facilities may be subject to additional requirements under NFPA 99 standard for healthcare facilities. It is important to consult with qualified electrical professionals to determine which standards and regulations apply to a particular project. The use of arc fault circuit interrupters, or of size, and ground fault circuit interrupters, or GFCIs, is also a critical aspect of modern electrical safety. SIs are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. GFCIs are designed to protect against ground faults, which can cause electrical shock hazards. The NEC requires the use of SIs and GFCIs in certain locations, such as bedrooms, living rooms, bathrooms, and kitchens. Regular testing of SIs and GFCIs is essential to ensure that they are functioning properly. Electrical panels should be inspected regularly to identify any potential problems. These inspections can be performed by qualified electricians or electrical inspectors. During an inspection, the electrician or inspector will check for signs of damage, corrosion, or overheating. They will also test the operation of circuit breakers and fuses and verify that all wiring connections are secure. Any problems that are identified during an inspection should be corrected promptly to prevent electrical hazards. Electrical safety is a shared responsibility. Homeowners, business owners, and electrical professionals all have a role to play in ensuring that electrical systems are safe and compliant. By following proper installation practices, conducting regular inspections, and staying up to date on the latest codes and standards, we can all help to prevent electrical accidents and protect people and property from harm. When selecting an electrical panel, it's important to consider the anticipated load and future expansion needs. Choosing a panel with sufficient capacity will prevent overloads and ensure that the electrical system can handle future demands. It's also important to select a panel that is appropriately rated for the environment in which it will be installed. For example, panels installed in damp or corrosive environments should be rated for those conditions. Proper maintenance of electrical panels is crucial for ensuring their safe and reliable operation. This includes keeping the panel clean and free of dust and debris, tightening any loose connections, and replacing any damaged components. Regular thermal imaging of electrical panels can help to identify hot spots that may indicate loose connections or other problems. Addressing these issues promptly can prevent equipment failures and electrical fires. The electrical panel's labeling should be clear, accurate, and up-to-date. This includes labeling each circuit breaker with its corresponding load and providing a circuit directory that accurately reflects the current configuration of the electrical system. Accurate labeling is essential for safe and efficient troubleshooting and maintenance. When making any changes to an electrical panel, such as adding or removing circuits, it's important to follow proper procedures and comply with all applicable codes and standards. This work should be performed by a qualified electrician who is familiar with NEC and local electrical codes. Improperly modified electrical panels can create serious safety hazards. Surge protection is an important consideration for protecting sensitive electronic equipment from voltage spikes and surges. Surge protective devices, or SPDs, can be installed at the electrical panel to protect the entire electrical system. These devices divert excess voltage to ground, preventing it from damaging connected equipment. When installing or modifying an electrical panel, it's important to obtain the necessary permits from the local building department. This ensures that the work is inspected and approved by qualified electrical inspectors. Working without permits can result in fines and other penalties. The electrical panel's location should be carefully considered to ensure that it is easily accessible for maintenance and repairs. It should also be located in a dry, well-ventilated area that is protected from physical damage. Avoid installing electrical panels in areas that are subject to flooding or other environmental hazards. The use of tamper-resistant receptacles is an important safety measure, especially in areas where children are present. These receptacles have internal shutters that prevent objects other than electrical plugs from being inserted into the slots. Tamper-resistant receptacles can help to prevent electrical shock injuries. Regular training for employees who work with or around electrical equipment is essential for promoting electrical safety in the workplace. This training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. Properly trained employees are more likely to recognize and avoid electrical hazards. The electrical panel's door should always be kept closed and latched to prevent unauthorized access. This is especially important in areas where children or the general public may be present. An open electrical panel can pose a serious safety hazard. When working on or around electrical equipment, it's important to use the proper personal protective equipment, or PPE. This may include insulated gloves, safety glasses, and flame-resistant clothing. PPE can help to protect workers from electrical shock, arc flash, and other electrical hazards. The use of ground fault circuit interrupter protection for temporary electrical power is an important safety measure on construction sites and other temporary work locations. GFCIs can help to prevent electrical shock injuries by interrupting the flow of electricity to ground in the event of a fault. Temporary power systems should be inspected regularly to ensure that they are safe and compliant. The electrical panel's wiring should be neatly organized and properly supported. This makes it easier to troubleshoot and maintain the panel and reduces the risk of accidental contact with energized conductors. Messy or disorganized wiring can create safety hazards. When disposing of old electrical panels or components, it's important to follow proper environmental regulations. Electrical equipment may contain hazardous materials such as mercury and lead, which must be disposed of properly to prevent environmental contamination. Contact your local waste management agency for information on proper disposal procedures. The NEC provides specific requirements for the installation of electrical panels in hazardous locations, such as areas where flammable gases or vapors are present. These requirements are designed to prevent explosions and fires. Electrical equipment installed in hazardous locations must be specially designed and certified for those environments. The use of arc flash hazard analysis is an important step in protecting workers from arc flash injuries. An arc flash hazard analysis identifies potential arc flash hazards and determines the appropriate level of PPE required to protect workers from those hazards. Arc flash hazard analysis is required by NFPA 70E. Regular inspections of electrical systems can help to identify potential energy efficiency improvements. These improvements can reduce energy consumption and save money on utility bills. Energy-efficient electrical equipment and practices can also help to reduce greenhouse gas emissions. The electrical panel's design should consider the potential for future expansion and upgrades. This may involve providing spare capacity in the panel and using modular components that can be easily added or removed. Planning for future expansion can save time and money in the long run. The use of smart electrical panels can provide valuable data on energy consumption and system performance. Smart panels can also be used to remotely monitor and control electrical loads. This information can help to improve energy efficiency and prevent equipment failures. The electrical panel's installation should comply with all applicable accessibility requirements, such as those specified in the Americans with Disabilities Act, or ADA. This ensures that people with disabilities can safely access and operate the electrical panel. Accessibility requirements may include providing adequate clearances around the panel and using controls that are easy to reach and operate. When selecting an electrical contractor, it's important to choose a company that is licensed, insured, and experienced in electrical panel installations. Check the contractor's references and verify that they have a good track record of providing safe and reliable service. A qualified electrical contractor will be familiar with the NEC and local electrical codes. Regular training for electrical workers on new technologies and best practices is essential for maintaining a skilled and competent workforce. This training can help to improve safety, productivity, and quality of work. Investing in employee training is a smart investment for electrical contractors. The electrical panel's grounding system should be tested regularly to ensure that it is functioning properly. This testing can be performed by a qualified electrician using a ground impedance tester. A properly functioning grounding system is essential for electrical safety. The electrical panel's labeling should be durable and resistant to fading or damage. This ensures that the labeling remains legible over time. Consider using engraved labels or other permanent marking methods. The electrical panel's installation should be coordinated with other building systems such as HVAC, plumbing, and fire protection. This helps to ensure that the electrical system is properly integrated with the other building systems and that there are no conflicts or interference. The electrical panel's design should consider the potential for electromagnetic interference, or EMI. EMI can disrupt the operation of sensitive electronic equipment. Shielding and filtering techniques can be used to reduce EMI. The electrical panel's installation should be inspected by a qualified third-party inspector. A third-party inspection provides an independent assessment of the electrical system's safety and compliance. This can help to identify potential problems that may have been missed by the electrical contractor. The electrical panel's design should consider the potential for voltage sags and swells. Voltage sags and swells can damage sensitive electronic equipment. Voltage regulators and other power conditioning equipment can be used to protect against voltage sags and swells. The electrical panel's installation should comply with all applicable environmental regulations. This may include requirements for the use of environmentally friendly materials and the proper disposal of waste. The electrical panel's design should consider the potential for harmonics. Harmonics are distortions of the electrical waveform that can cause overheating and equipment failures. Harmonic filters can be used to reduce harmonics. The electrical panel's installation should be documented with accurate as-built drawings. These drawings provide a record of the electrical system's configuration and can be used for future maintenance and repairs. The electrical panel's design should consider the potential for power outages. Backup power systems, such as generators and uninterruptible power supplies, or UPSs, can be used to provide power during outages. The electrical panel's installation should be protected from physical damage. This may involve using bollards or other protective barriers. The electrical panel's design should consider the potential for vandalism. Tamper-proof hardware and security cameras can be used to deter vandalism. The electrical panel's installation should comply with all applicable fire safety regulations. This may include requirements for fire-resistant enclosures and fire-stopping materials. The electrical panel's design should consider the potential for seismic activity. Seismic bracing can be used to protect the panel from damage during earthquakes. The electrical panel's installation should be inspected by a qualified structural engineer. A structural engineer can verify that the panel is properly supported and that it is capable of withstanding the loads imposed on it. The electrical panel's design should consider the potential for lightning strikes. Lightning protection systems can be used to protect the panel from damage caused by lightning. The electrical panel's installation should be inspected by a qualified lightning protection specialist. A lightning protection specialist can verify that the lightning protection system is properly installed and that it is capable of protecting the panel from lightning strikes. The electrical panel's design should consider the potential for corrosion. Corrosion-resistant materials can be used to protect the panel from corrosion. The electrical panel's installation should be inspected by a qualified corrosion control specialist. A corrosion control specialist can verify that the panel is properly protected from corrosion. The electrical panel's design should consider the potential for mold growth. Mold-resistant materials can be used to protect the panel from mold growth. The electrical panel's installation should be inspected by a qualified mold remediation specialist. A mold remediation specialist can verify that the panel is properly protected from mold growth. The electrical panel's design should consider the potential for insect infestation. Insect-resistant materials can be used to protect the panel from insect infestation. The electrical panel's installation should be inspected by a qualified pest control specialist. A pest control specialist can verify that the panel is properly protected from insect infestation. The electrical panel's design should consider the potential for rodent infestation. Rodent-resistant materials can be used to protect the panel from rodent infestation. The electrical panel's installation should be inspected by a qualified rodent control specialist. A rodent control specialist can verify that the panel is properly protected from rodent infestation.